Okay, so we're gonna do both sections today, 1, 2, and 3. First thing we're gonna do has to do with those straight edges. You should be able to do this without my instruction at this point, but I will help you if you would like. Right at the beginning, it's called the ruler postulate. It's not worth the ink that it's written on. It's just ridiculous. But we're gonna take a look at what we're gonna do with it. In example 1, it says measure the length of ST, that thing that's in front of you there. Measure it to the nearest tenth of a centimeter. So first of all, choose the centimeter side of your ruler. And understand that these rulers' ends are not where 0 is, duh, right? Isn't that kind of a duh? Put the 0 on S and measure it, not the end of the ruler. Go on the centimeter side, get out there, and can anybody tell me what they believe the length of that is with measuring? I realize it's right below you, the solution, but I want to know if you're getting the same thing they are. How long do you think that ST is by measuring in your book?
3.4.
3.4? Because each one of the little millimeter things is a point, right? A point, there's 4 of them out. Guess what I'm getting?
3.4.
No, 2.4. What's that? Nope, I didn't have it on the end. I put it right there. And mine measured 2.4, right to there. That's all the longer I got.
Is this in centimeters?
Ours is in millimeters.
Because you're not aware of this. It's because of my book. Your book is sitting here in front of me, but it's been reduced in the printing. You know what I mean? Mine is only 2.4. You are correct in saying 3.4 because your books are bigger. That's why. Just an interesting thing to note. Very first time I taught this, I measured that and I go, what are you, nuts? You guys are crazy. It's not even close to 3.4. And it dawned on me, oh, yeah, you are correct. Okay. Anyway, so I want you to measure just numbers 1 and 4. Just 1 and 4, but we would pay attention to the instructions on the bottom of page 12. It says use a ruler to measure the length of each segment to the nearest 1/8 of an inch. Now what are you going to do? Get over here on the inch side, and remember, the end of the ruler is not 0. And see if you can measure to the nearest 1/8 of an inch, number 1 and 4 in the monitoring progress. But don't tell me, and don't tell anybody else. Nearest 1/8 of an inch. I'm not going to measure mine, they're way off. They're not even close. Are any of you struggling with the fact that your ruler is marked in, what's your ruler mark up? What's the smallest marking on the inch side? 16. So make sure you're counting every other one when you're counting 8s. Okay, you're doing 1/8 of an inch. Would anyone like to share with me how long you believe number 1 is? Go ahead.
1 and 5.
You got 1 and 5/8. Anybody else get that?
Yeah.
That's what it is? Okay. Anybody else? Someone else, can you tell me how long number 4 is?
1 and 1/4.
1 and 1/4? Okay. Anybody else get that? Everybody else get that?
Yeah.
We would actually, if it's to the nearest 1/8 and we were reporting the 1/8, it would be 2/8. But that's not, I'm not suggesting you do that. You did get it to the nearest 1/8 by reducing the 2/8 part to 1/4. So that's correct. Okay, so that was boring, right? Okay, I thought it was. We're not going to do the construction. Go up to the core concept. This is almost as bad. But there's one important concept you got to get. It's not hard, but you got to get it right up front if you're going to be able to read this book and also understand what I'm saying. And it's the difference between the words congruent and equal. If I have a, oh, that's the one. I'm trying to find that. That's the one that doesn't write. If I have 2 segments, and I'm not going to put them, I'm going to do it like this. And just pretend with me that if I tell you that this is 10, and this is 10, and this is segment AB and segment CD, you could say, and we will say, using it rather loosely, the term, we will say that AB is equal to CD. When really it isn't. And it all depends on whether what you're focusing on is the length of those segments or the segments themselves. If I take these 10s off and I say to you, AB equals CD, What I mean is this is a very, very subtle way of writing things. The concept isn't hard, but you got to get the notation. If I say this, AB equals CD, that statement right there means that they are the same length. Notice I didn't put any bars, I didn't put any segment symbols across there. If you include segment symbols, you can't use this symbol. If I say this, and you guys are going to go, that's dumb. That's really stupid that there's any difference at all. If I say it like this instead, and I put bars across here like this, then I have to include a little tilde right here, a little squiggly. That symbol means congruent, and that's how you say it. And so you say here, you say AB equals CD. And down here, when you read this, you say segment AB is congruent to segment CD. And here's the difference. And it's subtle, and it seems kind of dumb in your minds, but you've got to know the difference. This statement right here says the segment which is AB looks exactly like the segment which is CD, but they are in different locations. That's what it means. There's a picture that when you see these little bars or rays or line symbols or whatever across these letters, you're talking about the picture of it, how it's drawn. We say when AB is this, I'm gonna get this straight. AB looks just like CD, but they're occupying different spaces. When we say this, we're actually talking about the number, this is a number. This is not a segment. This is a number associated with the segment. It's the length of the segment. This means length of AB. So if I tell you that's 10 and this is 10, then we can say the length of AB equals the length of CD. But we will not put the word length in anymore. We will just say AB equals CD. And especially when you see it written this way, it means 10 equals 10, not this picture looks like this one. This means 10 equals 10. Because this, without any symbols across it, means the length of it. So the length 10 equals the length 10. This means the picture looks like the picture, but they're in different places. Here we say equals, here we say congruent. You see it? See the difference? Okay, you need to understand those two subtle differences. Come in.
Is Ben Owens in here?
I don't know, is Ben in here? Yeah, right there.
See,
Okay. All right. So make that distinction carefully. After a while, after we've played with this enough, or quite a while, we're just going to go with this. This is going to be the important part. But for right now, they're both important. You got to be able to make the distinction in your mind. These are numbers. These are pictures. Both indicate that we've got the same. Just that congruence means it's in a different location. Okay, so that's what they're trying to tell you in that core concept. So take a look at example 2. And it says, plot J, K, L, and M. Okay, in order for this to show up on the video, I've got to move this. Hang on. So we're going to plot J, K, L, and M on that grid, and I hope if you're viewing this, you can see that. Just a little bit more. Okay, so what are the coordinates of J? Negative 3, 4. Okay, so this is J. Okay, next.
2, 4.
2, 4?
Is K.
Is 2, 4?
Yeah.
So this is K here. Okay.
L is 1, 3.
1, 3. That's L. Okay.
And then 1, -2.
1, -2 here. And that's M? Okay, so that's the first thing it said to do. Plot those. Okay, plot those points. Then determine whether JK equals LM. So now we're going to associate 2 points at a time. Here's JK, so we're actually going to draw a segment between them. And here's LM. The question is that they're asking, now that we've connected them and see how they're related, it says determine whether JK and LM are congruent. They have to look exactly alike, but occupy different space, which means to look exactly alike, they have to be the same length. Are they?
Yes.
We could count. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yep. Both segments, both 5. Different locations means they're congruent. Yes.
They don't need to be like both horizontal or both vertical.
Nope.
Okay.
Need to look alike. They can occupy different space and be oriented differently. One of them could even be slanted as long as it's 5 units long. That's hard to do on this, make it 5 units long and make it slanted, but we could. Okay, so the answer to that is yes. After we plotted the points, we connected them and we counted them. going to become important that you be able to find the lengths of these things later. It's going to be important that you be able to figure the lengths. I'll talk about that in a minute. But anyway, certainly they are congruent. Moving on. Okay, you're going to come in working with your first postulate that you will use in proofs. We'll come back to this and make sure that you've got it listed and know how to use it. But for right now, we just want to get you kind of used to what's happening here. This is an easy concept. If I draw another segment here, call it PQ. And on this same segment, somewhere between it, on the segment, not out here in space somewhere, but on the segment, I put another one, call it R, anywhere on the segment between them. Guess what? Guess what we say? We say R is between P and Q. That's what we say. It's an actual geometric term. Okay, but it leads to this thing called the segment addition postulate. It's also kind of, when you see it, you go, duh. As a matter of fact, when I looked at your guys' pre-tests, 0 of you missed this concept. You all get this already, so I'm not going to spend a huge amount of time on it. What this says, if you got this situation and R is actually on the segment between P and Q, then we know that PR, remember that's a number? It's the length of PR. Added to this number, RQ, has to equal this number, PQ. Duh. Right? Isn't that a duh? It should be. It should not. That should not be difficult. So that if I actually assign some numbers here, if I put a 3 here and a 7 here, you should be able to tell me the PQ is 10. You should also be able to go in the opposite direction, and this is not segment subtraction. It's still an application of segment addition in a slightly different way. If I tell but I tell you that this up here is 13, then you should be able to tell me the length of PR, this time by subtraction. Because here's what it comes down to. If you let this be X, you're saying, according to what this says, which is addition, you're saying X plus 7 equals 13, which requires you to subtract to solve. But it's still segment addition. Y'all see it? Okay. That's the concept of that. It's not that big a deal. All right. So I'm not going to do example 3. It's a bit insulting. It's just crazy. Example 4 is a little, not quite so easy, but almost. It's the same idea. Take a look at it. It says the city shown on the map lie approximately in a straight line. We're going to assume it is straight. Find the distance from Tulsa to Oklahoma. Find the distance from Tulsa, Oklahoma to St. Louis, Missouri. So get your eyeballs on Tulsa and get your eyeballs on St. Louis and look at what else is on the map. How would you figure that out? Don't do it for me. Just tell me how you would figure it out. 738 minus 377. It's just like this, only the numbers are bigger. Right? Yes, it's not that big a deal. It's hardly worth even talking about. So turn the page, and that's why we're doing 2 sections today. That's ridiculous that took up a whole section. I'm sorry?
Is that what we're gonna have like double the homework?
Yep. This one's going to take you about 5 minutes. Okay? It's not going to be hard. Okay? But it's important that we get the concepts out and that you practice with them a little bit. They're not hard. I would give you the assignment, but then several of you would get started on this one instead of listening to me, so I'm not giving you the assignment. I'll come back and give it to you in a minute. Section 1.3 begins on page 20. It's called the midpoint and distance formula. These are nearly as easy until we get to the end of the section. Then they get pretty rough. It's going to take some explanation. That's why I'm going to use most of the time. So, I'm like a catcher in a ball game. I can see the whole game, whereas if you are players, you can only see portions of it that pertain to you. And I'm telling you right now, I'm losing several of you to sleep. If you want to take just a second before I start on this, get up and go get a drink so get your blood going again. That's fine. You cannot sleep through this. Anybody want to go get a drink? Stand up. The ones that are asleep can't hear me. So. Okay. We'll continue. Here we go. Midpoint and segment bisectors. Again, these are subtle little things that are not hard, but you got to pay attention, or you're gonna miss the differences. Okay, so give myself a segment again. I'll call it AB for lack of creativity today. If I go right to the point that is right on the segment, right smack in between. I mean, right smack in between, meaning this half is just as long as this half. The halves are equal to each other. If I go to that point, there are several things that we can call a bisector. If it's just a point, we actually call this a midpoint. That's pretty easy. But there are lots of things that can cut a segment in half. Points are one of them, and we call them midpoints. And what it means is that if I give a name to this, it means that AC is equal to CB if I tell you C is a midpoint. AB, this half, equals this half. So we would write that. AC equals CB. If I say C is a midpoint, this is what you know. Pretty easy, right? But there are other things, other geometric things that can cut it in half. So if instead of the midpoint there, I have something coming out from space, a line, smacks that thing right in half. So that, and by the way, this is the way we mark it, so that this segment is equal to this one. That's how we mark it on the picture. Then yes, that's the midpoint, but that's not the issue here. This did the cutting. And if it's line L, we say that L bisected AB. L's the cutter. And it's a line this time. When we say line L bisected AB. What is this? We really don't care in this context. It's that this did the smacking in half. So L is a bisector of AB when we know that this half equals this half and it was cut by this. If we restrict it to a ray, try to get all of these things together. It's not hard. Like I said, if I call this ray PQ, then I would say PQ bisects AB. Ray PQ, and this is how you write it. Ray PQ bisects. You can abbreviate it. Bisects segment AB. That's talking about the picture. Okay? But because P is now located, we can also say P is the midpoint because it's talking about just the point of AB. Both are correct in this case. Yes.
For it to be called a midpoint, does it have to be right in the middle?
Yes. And it has to be on the segment. And when we say has to be in the middle, what we mean by that, because we always have to define things with an equation. What we mean by middle is this half equals this one. We get the equation. AP equals PB. That equation is what we get from the fact that this is a midpoint. Okay? So saying it's right in the middle is no good to us geometrically. When I tell you something's a midpoint, you say that means AP equals PB. And I know you're going, but it's not what middle means. Yes, but with equations, we've got something to work with. With the statement that it's in the middle, we don't. Okay. I know, and the more you play with them, the more you get used to it. It'll be rough, but you'll get it. Take a look at the monitoring progress, bottom of page 20. I don't expect you to actually do this. I just want you to tell me what you would do, what you would do to things to answer the question. At the very bottom of page 20, we have numbers 1 and 2, and it says identify bisector of PQ. In number 1, what is the segment bisector?
Ray MN.
That's correct. That's what you say, ray MN. Then find PQ, and notice there's no bar across it, which means find how long it is. How long is PQ? What would you do?
3 6/8.
I don't want to know what it is. I want to know what you would do.
Oh, I would.
5x minus 3 equals 11.
Raise your hand and talk to me. Go ahead.
5x minus 3 equals 11 minus 2x.
Where are you?
On number 3? Or,
I'm on number 1, monitoring progress, bottom of page 20.
no.
Yeah, over here. Yeah, over here. Okay. Well,
Well, if it's,
what would you do?
I took the 1 7/8 and added, just have it right through because there's.
Times it by 2 or add it to 1/7/8? Because that little guy's the same length, right? And PQ makes up both of them. Since they're the same length, you would double 1/7/8 or add 1/7/8 to 1/7/8, right? Okay, what is the bisector of PQ in number 2?
And
You would say the midpoint M. Yep, that's the bisector. That's the cutter. Is midpoint M. And how would you find the length of PQ here? Anyone else? Go ahead in the back.
Multiply 2 2/7 by 2.
Good. Now, how would you actually accomplish that? Would you do that on paper?
No, I just do it in my head.
You would? Good for you. Anybody else? Would you do it on paper? Because what I'm suggesting to you is if you get your calculator and know how to operate the ABC button, you can do it quickly there. I encourage that. Okay, look at example 2. This is a little more what you were looking at. What's your name?
Down.
Down. This is a little more about what Down was looking at when we talking about X's and stuff. We can do that too. It says in example 2, point M is the midpoint of VW. And immediately you think, okay, Not that W's in the middle. No, that's not what you think. You think, oh, that means that VM equals MW. That's what it means. And so you write 4x minus 1 equals 3x plus 3 and solve it. I'm here to tell you guys, if you were crappy algebra students, you're not going to do very well here. We assume you know how to solve that equation. The geometry is putting it together. Then you use your algebra skills to solve it. If your algebra skills suck, you don't. Think about getting out of it. Because we're going to be using algebra over and over and over. You got to be pretty good at it. So you were doing number 3, Dylan. Now tell me what you would do to answer the question number 3. How you would go about beginning on this.
So 5x minus 3 equals 11 minus 2x.
That's correct. And I will do that for you on the board in just a minute. But the first part of it said, identify the segment bisector of PQ. What is the segment bisector of PQ?
L.
So you would say L is the bisector, and then you would set up that equation just like you said. So 5x minus 3, 11 minus 2x. 5x minus 3 equals 11 minus 2x. Does anybody not understand why you would write this? The definition of a midpoint means that the two halves are equal. If you cut something in half, it means this half of that on this side of the cutter is equal to the half that's on this side of the cutter. So whatever this is equals whatever this is. That's what we're using. And if you look at 3 there on the monitoring progress, it says, then find the measure of PQ or MQ. We can't find the measure of MQ unless we can find X. So that's the first thing is to find X. Does that make sense? I see where you mistake or where you would.
I was looking at like the one on the top.
Oh.
This is 4x minus
I'm sorry. I dropped clear down to the monitoring progress. Sorry about that.
that's my bad.
Now we're good?
Yeah.
Okay. So we would write that equation that Dallin suggested, and then we would solve it. And you should be able to do this arithmetic fairly quickly. Y'all see what happened there?
Yeah.
2 things. This is not the answer, people. It was in algebra. This is not the answer. This will lead to the answer. What do they want us to find?
The length of
The length of MQ. So we will take 2 and plug it into MQ. This was the length of MQ. So now we will have 11 minus 2 times 2, which is 11 minus 4. So what if they had said not find MQ in this very same problem? What if they had said find PQ? Yeah, plug it into either one of those to find the length of one of the little guys, right? And do it. Does that make sense? If they asked you to find PQ instead, you would find X by this relationship that if a midpoint you have this half equals this half, you'd find X, and then you would plug it into one of the halves. Either one. And double it to answer the question. Yeah? That make sense? Good. Moving on. Okay, here's where we got to slow it down a little bit because you're going to learn the midpoint formula and the distance formula as it pertains to this 2-dimensional grid. Everything we've done so far up here is 1-dimensional. I mean, we just had a segment that we cut. Okay, and there's a lot that I need to do to lead you to understand this. So just stay with me and try not to go to sleep. Okay. I guess I'm just going to pick 2 arbitrary points here. Let's say I'm doing this. It's not in your book, so don't try to figure out what I'm doing out of the book. This is me, so pay attention up here. If I have a point A, which is -4, 7, and another point B, which is 3, -5. What we would do, what I want to do is find the location on this grid that is the midpoint of this segment. Now this isn't going to be horizontal or vertical like we saw before. It's not going to be cut in half like the drawings I had here. We actually put them on the grid. It's going to be slanty. We got to see if we can find the location of the midpoint. So first we plot them. 1, 2, 3, 4, 7, they're right there. And 3, negative, that's A. And 3, -5. 3, -5. There's B. And I'm going to freehand this. I'm not sure I'm going to be able to make it nice and straight. We'll try. It's not very straight. But that's our segment AB. And what I want to know is where on this grid, with respect to the origin idea, where is the midpoint? Now, you can probably visualize it pretty well. It looks to me like it's about right there to me. But visualizing it is not enough. You've got to be able to figure it out. Now, I'm here to tell you, folks, middle, not midpoint, but middle means average. So middle point, which is what midpoint is abbreviating, means average point. Averaging is what we're going to do to find this, because here's the idea. This is just the idea behind it. If I were to make a triangle out of this, what we're saying is, and this should make good sense in your mind, if I could find the middle of this line, and if I could find the middle of this line, and see where they meet there, that should be the middle of the black line. Does that make any sense? Now, why did I do horizontal and vertical? I'll tell you, because these things, this is all about horizontal. These two things, this X here and this X here, is all about how you move horizontally, right? This is all about how you move vertically. They're vertical moves, up and down. So if I could find out or horizontally, that's the horizontal ones right here. If I could find out where those two guys, where the middle of that is, which would be about right here. That's the horizontal ones. Here's your -4 here. There's the 3 there. If I could find the middle of that, that would be a nice thing to know. If I could find the middle of that, it'd be a nice thing to know. Well, I'm going to average them. The middle of this is going to be -4 plus 3 divided by 2, because that's what middle means. Average it. Average that horizontal point and that horizontal piece, average them together, and you get -1/2, right? And look where I drew the X. With respect to the origin, it's at -1/2. See it? You see what I'm doing? So to find the middle of this one, I will average the vertical components, or the vertical things, which is the Y. So I would take 7 and add -5 and divide it by 2. 7 and -5 is 2. 2 over 2 is 1. And so this one would have a midpoint here. And so I found that one by visualizing. I did pretty well. Where these two converge, right where that midpoint is. But what's its location? The location is, with respect to the origin, -1/2, 1. That's the location of the point that's between these two. So let me summarize it for you. If instead, I'm going to leave this up here. If instead I have 2 points, we'll call them P and Q. But they're nothing specific like these numbers were. We're going to generalize now. So P is located at X1, Y1, and Q is located at X2, Y2. They're different from one another, but we don't know where they are for sure. If you want to find the midpoint, just like we did here, if you want to find the midpoint between these two, you would add the X's and divide by 2, because we need the average of the horizontal piece, comma, average of the vertical piece. And it is a point. But you find this piece of it by averaging these two. And you find this piece of it by averaging these two. Does that make good sense to you? This is the midpoint formula. Write it down, figure out where to find it in your book, something. You will be using the actual formula. So rather than figuring this out on our own,
Wait,
what? Question?
so we multiply M by the,
No, M, that just means the midpoint, the midpoint M is this point. When you have a capital letter right next to a set of coordinates, it doesn't mean to multiply. It just means M is located here. Capital letter. Okay, good question. Notation always, I get too used to it. I can't remember that you haven't seen it. So if I give you 2 points, let's see if we can bring it all home here. If I give you 2 points, let's say R and S, and I tell you that R is 14.3 and S is -7.5. Where's the midpoint? I don't think I'm going to use 14 because I want to be able to graph it on here. So I'm going to say 9. 9.3. Okay, so I'm going to change my mind. How do we find the midpoint without graphing it? It would be M, like that, because that's what I mean. I'm looking for my midpoint. You can do this in your head because you guys are sharp. I know you are. But remember what we do to find this? We add these, and if we add those, you get 2 divided by 2 is 1. So you can do the arithmetic in your head. What is the average of this one? No, that's what they add up to. What's the average? 4. I was asking you to do the whole thing all together. So anyone who's lost, because I didn't show you anything about how to find these. We did it all in our heads. Any question? Please speak up. So to prove it to you or to show you, I'm going to now that we've got it, I'm going to actually show you that is the midpoint, even though we never graphed them. 9.3 is right here. -7.5 is right here. And I'm claiming that the midpoint is 1, 4. Does that look like the midpoint to you? Okay, so that's your midpoint formula, and this is why it works. It's averaging. Mid means middle, and middle means average. So you average the x's and you average the y's, and those two numbers become the coordinates of your midpoint. Oh, I can't come over here because I'm going to stay on the screen. Okay. All right, so now we're going to switch gears here a little bit. We'll talk about distance. How far is it between 2 points? And this is going to take a little bit to develop, so try to stay with me. And then you'll understand where it comes from, and maybe you'll remember it, hopefully. So I want you to consider this, just a one-dimensional number line for just a minute. I'm going to put a 0 here, and -5 here, and -12 here, 2. These are not necessarily to scale. 10 here. And I'm going to put letters on them, A, B, C, and D, and E. What is the distance between B and E? Anyone? Sorry? 15. Now, who said 15? Because you're correct. It's okay. And how do you get 15?
You add the 10 and -5. It's a good like subtract them from each other. So it's like 5 to 0 is 5, and then 0 to 10 is 10. And you add 5 to 10.
Okay, so you're saying you went from you went from here up to here to get rid of your negatives. That was an actual distance of 5. And then you went on here to 10 and got 15. So this chunk was 5 and this chunk was 10. So you got 15. That's segment addition, by the way. That's not what we're after, but that is what happened. Did anybody figure it any other way? It is 15, but is there any other way to figure it? So can anybody tell me the distance between D and E? Well, 2 and 10 isn't 8.
Find the difference.
We added 5 and 10 to get the 15, but 2 and 10 is not 8.
You subtract.
Oh, you subtracted there? What's the distance from A to B?
7.
7. And how do you do that? Did you add -12 and -5? That's -17. Did you subtract 12 and 5? But they're negative. How did that work?
You're not going from negative to positive. You're staying in the same.
Seems like a lot of rules to memorize, right? Let me show you one thing to think about. In all of these cases, here's what you did. If you want to find the distance from A to B, and I know you're saying, that isn't what I did. I bet it is. In your brain, somewhere or another, we'll be able to dredge this out just like I'm writing it. What you did to get from A to B was you took, well, this is what happened. You took the coordinates of A, and you subtracted the coordinates of B, and absolute valued them. Crazy, huh? So even a little more simple way of writing that is you could say you subtract, if you're trying to find the distance from one point to another, whatever they are, if you know their coordinates, you subtract the numbers and take the positive value of that, whatever it is, because that's what the absolute value does to you. So if we wanted to find the distance from B to E, we could take 10 minus -5 and absolute value that. That would be 15 because this is 10 plus 5, which is what you did. Or I could take 5 minus -5 minus 10. That would give me -15, but the absolute of that is 15. So it doesn't matter which one you start with, as long as you just take the positive result of their difference. This was -15, but I said, no, it's 15. So you just ignore the sign, basically, is what I'm saying. So using this idea, what is the distance from B to D?
7.
I'm hearing 7. All the rest of you getting 7?
Yeah.
Now you could count. You could go up 5 to 0 and then 2 more, and that gives you 7. But that's not always the best way to do it. This is the best way to do it because it works every time. So -5 minus 2 is -7, but you make it 7. What's 2 minus -5? 2 minus -5 plus 7. Either way, you get 7 if you absolute value it, right? So it's the difference between the numbers. Choose the positive. Done. See it? So you got to subtract. Okay, what if I make the number line this way? And put a 0 here and a 2 here. And I'm not going to use the same numbers. Let's say 7 here, and down here I got a -3 and -8. Does it matter? What's the difference between, what's the distance from A to D?
10.
10. What's the distance from B to E?
4.
Try again. What's the difference from B to E? 10. What's the distance from B to D? 5. So it doesn't really matter if we make the number line this way, right? You're going to see why I brought that up here in just a second. So now we're going to take a leap. And we're going to bring these ideas back to you, and you try to remember what we learned here so that you can understand what's coming up. If I put a point, I'll put a point right here. I'm just arbitrarily picking these things out. Let's put another one up here, right there. And I want to know, how long is that? Not where the midpoint is, how long is that? And when I say how long is that, I mean measured in these units. In these little inch units right here. How many inches go up along it? You can't count that because it's slanty. You can't count from here to here and say that's 1. That's slightly longer than 1 because this is 1, right? Can't count from here to here. That's slightly longer than 1. So is that. And that one doesn't even hit right. I mean, it gets cut off before we get to the next grid. You can't count these. But I still want to know how long it is. And so I'm going to associate it with lines or segments that I can count or figure. Whoops, I screwed that up. Make that straight. And if you do that, you make these lines as they start here and go horizontal until it's right below that one, and then we go up to that one, we got a right triangle. And you all know the Pythagorean theorem, or you had better. In order to apply the Pythagorean theorem to find the length of that black thing right there, I need to know the length of this leg, and I need to know the length of this leg. And in this scenario, I can count them both. So I'm going to count them first, and I'm going to show you a better way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one is 1, 2, 3, 4, 5, 6. And so what we would do to apply the Pythagorean theorem, if you recall, I hope you do, is to say 11 squared plus 6 squared is equal to D, the distance along the black line, squared. Because the black line distance is the hypotenuse, and that's Pythagorean theorem. Do y'all recognize it? So then you would do the math. 121 plus 36 is equal to D squared. 121 plus 36 is what, 157? And then you would square root that. What's the square root of 157? It's 12 point something. Anybody have a calculator?
12.52.
Okay. So right around 12 and a half units, right? Okay, so what I want to do to demonstrate that for you is I'm going to measure out on this. I'm actually going to mark it with my marker, 12 and a half units. That's going to be kind of rough. Let's see. If I start here, this would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half. So about right there. So I'm going to mark it on this ruler and see if that's how long it is, because I have these units. Oh, it's 30 centimeters. Okay. Voila. Look at that. 30 centimeters. Right on the money. Pythagorean theorem is true. Testimony. Okay. This is the part that I want you to get that's going to tie what I erased over here to what we're trying to do. What are the coordinates of this point right there? It's actually -6, -2. Got to go left before you go down. Okay. And what are the coordinates of this point right here? 5, 4. So what I'm going to try to teach you now, show you what to do now, is rather than draw it out every time and count the legs, because sometimes you can't. Like, for example, if you have a point that's -478, -222, and another point over there that's 278, and another point that's up, it's 278, 122, you're not going to want to draw that out and count. Or if you have coordinates that are made up of fractions or decimals, that's going to be a difficult thing to count. You can't always draw the right triangle. So my question is, how could we tie the actual coordinates of the endpoints together so that we can use this Pythagorean theorem without drawing it out? In other words, how could I find this 11 without counting?
We do like 5 minus -6.
Because look, folks, we are trying to find the distance, to find the length of this leg right here. We're trying to find the distance from here to here on this number line, which I just talked to you about. That one's 5, that one's -6, and 5 minus -6 is 11. So I can find the length of this without counting by using that distance formula. Same thing here. That's why I wanted to show you the vertical one, the verticalness of it. Okay. And so to find the length of this without counting, we go to the vertical part of the points and look, 4 minus -2 is 6. Because I'm going from here on this number line down to here, and the distance between those 2 points is 4 minus -6, which is the length of that leg. You following? So what I'm trying to get to now is this. If I took, I'll show you what it would be in here without the counting of the 11 and the 6. All I know is the coordinates of the endpoints now. I don't know this green. I don't know the counting. I don't know any of that stuff. So I have -6, -2, and the other point is 5, 4. We'll pretend I don't have a picture here at all. You can keep looking back at this. But to find the length of the horizontal leg, I would take 5 minus -6 and absolute value it, right? Now, here's another leap in math. Stay with me. I don't need to absolute value it because in Pythagorean theorem, whatever this is, whether it's positive or negative, this one will turn out positive. I could just as easily have gone -6 minus 5 and got -11. Either way, I'm going to square it, which means I don't need the absolute values. It can turn out positive anyway. Because when you square things, it always turns out positive. Do you agree? Okay. To that, that's where I get my 11 from. To that, I'm going to add -2 minus 4. That one is negative, but I don't need the absolute values because I'm going to square it. And whatever that is equal to d squared. But in order to write it all out so that I have d all by itself, I'm going to square root everything. That'll get rid of this. Does that make any sense to you? That is Pythagorean theorem. It's just that we found the lengths. Instead of counting them, we figured them. So in general now, if I don't have specific points, if I have 2 general points like P, x1, y1, Q, x2, y2, and I want to know the distance between them, how far apart they are measured in those grid markers, then the distance between P and Q, and I put a little PQ to remind myself what I'm doing in case I've got a whole bunch of other points or something. The distance from P to Q is equal to the square root of the difference in the x's squared plus the difference in the y's squared. And I put those backwards on purpose because it doesn't matter. Just find a difference because when you square it, it'll turn out positive. You don't have to do a 2 here and a 2 here. I'm just demonstrating that you don't have to have these subtracted in order. Just subtract them and square them. So let me give you 2 other points now that we're not going to graph and see if we can find the distance without graphing. And then I'll prove to you that they're that long if you want. It's going to be, let's say, 5, 8, and -7, 4. I want to find the distance between those two. So to do that and apply this formula we just discovered, it's going to be distance equals square root. Big old monster here. But you can do the arithmetic in your head if you know what you're doing. What is 5 minus -7? Because that's what I'm going to do first, to subtract the x. 5 minus -7 is 12. What's 12 squared? 144. So I can write that right here without, I did all that math. I did all of that together. Okay, what am I going to write here? Plus what? Keep going. Keep doing it in your head. 8 minus 4 and then 16. 8 minus 4 is 4. Squared is 16. Because you got to square it. You with me? What's 144 and 16? 160? Is that right?
Yeah.
Okay. What's the square root of 160 approximately to the nearest hundredth? 12.65. Okay, so if I put those 2 points on there, 5, 8, and -7, 4. Supposed to be around 12.5. Remember that was about 30 centimeters? This one's going to be just slightly longer than that. About 30 centimeters it was, remember? Oh, it's a little bit longer than that. 30. It's 33, but remember, we're measuring in these, and we're just a little bit longer than that. Did I get those plotted right? I don't think I did. I was doing 5, 8. Sorry. I was going to say, that shouldn't be that far off. I can redo it. Plotted the point bad.
5, 8. Let me measure that one. Oh, that feels better. It's a little bit more than 30, but not by much. It was way over 30 before because I thought about it.
Anyway, that's your distance formula, and when I refer to it in the future and I say distance formula is Pythagorean theorem, this is what I mean. It is Pythagorean theorem. It's just you got to figure the lengths of the legs by subtraction using distance. That's all. It's Pythagorean theorem. Oh, look at that. We made it. Got 4 minutes to go. Got 2 seconds left. Here's the assignments. The midpoint formula and the distance formula on this grid are the ones you got to come away with from section 1 grid. Hopefully you have them written down or taken a picture or something. The exercises on 1, 2 are these. Are you ready? Get ready to write. 1, 3, 5, 9 through 22, 25 through, no, 25, just 25, comma, sorry. 27 to 29, 31, 33, and 36. And that seems like a lot, but you're going to whip through it, I promise. Not gonna be ready. On section 1-3, this may slow you down a little more. I want you to do 3, 5, 7 through 10, 15 to 31 odd, 32 to 34, hang in there, 32 to 34, 37, 39, and 46 to 49. Anybody need me to repeat that? Okay, that one was 3, 5, 7 through 10. Are you with me there? 15 to 31 odd, 32 to 34, 37, 39, and 46 to 49.
You've got separate papers.
Yes, these are 2 different assignments. 2 separate assignments. Do them on separately. Please leave yours. No, take your straight edges home. Just stick them in your book. Return them tomorrow. You're gonna need to measure a few things on your exercises.
Wait, keep these?
Yeah, you're gonna have to measure some things too. Bring it back tomorrow. Don't break it. Don't scratch it. Andrew Cavagna, are you still there? Keep your lunch card.
Usually we got a game, 2 games.
Oh, we're in the video.
Yes, that's hot.
Riley's probably presented. We're on YouTube, we're famous. You got it.
Sorry, forgot to stop this. There you go.